Hi guys, how are you?
Hello.
Oh, hello, we're fine. How about you guys?
I'm a little tired. It's a little late here, so I I'm also hungry. I want to eat something. It's nice to see you again.
It's really nice to see you guys.
Right. So, do you want to start, guys, or shall we start?
You can start.
So, for our last activity, we choose China as the country of um, con- the conversion of waste to energy. So, for the short introduction,
The urban growth projection for the coming decades brings with it new challenges. One of these is the issue of how to manage the waste that is generated, which is increasing at an alarming rate, particularly in specific areas of the planet.
so China is considered as one of the largest municipal waste producer in the world that generates as much as 175 million tons of waste annually. And because of that, they projected that hundreds of additional landfills and waste to energy plants will need to build in China in order to address the increasing waste management crisis. So the three the country has three main strategies for eliminating waste management. It is the landfills, the incineration, and the composting.
Given that MSW management includes the collection, transport, treatment, and disposal of waste, composing for countries like China, still has a limited amount compared to landfills. MSW's organic fraction is typically mixed with all kinds of waste, including plastics, metals, healthcare waste, and industrial waste that result in low compost quality and a real risk of heavy metals being introduced into agricultural soils.
So, storing and recycling waste are fast becoming a specific sector that requires efficient and clean technological solutions. So, China is aiming to go one step further by focusing its efforts on converting waste into energy at never before seen levels. So, the latest and impressive project aimed at contributing to this goal can be found at the mega plant that is being built in the city of Shenzhen.
Shenzhen and the new generation of incineration plants. More waste than any other city in the world is created by Chinese cities. The city must deal with about 15,000 tons of waste every day in the case of Shenzhen. The rise of
So,
Shenzhen's. Okay, go.
sorry. So in the case of Shenzhen and the company behind the project, which is the HSL company, the city has to deal with around 15,000 tons of waste energy. And to address this kind of issue, the architects of the SHL company proposed a solution to build a giant plant that will cover the area and is capable of incinerating almost one third of the current waste and producing electricity from the city.
The rise of Shenzhen's population is. I'll just cut that. Okay. How does China waste to energy? How does waste to energy work in China? The system captures heat from the incinerating unused waste materials, in which it drives the production of electricity by a turbine. The burning waste releases toxic CO2 emissions into the environment at the level of an average landfill site where most of the Shenzhen's waste ends up according to the architects. With more than 300 plants in operation, China has the largest installed waste-to-energy capacity of any region. This ability has risen by 26% annually over the past years.
So such treatment reduces waste volumes by 90% while treated leachate, the highly toxic liquid from municipal solid waste, can be put to use. So by substituting energy from burnt trash for fossil fuel combustion and also by avoiding methane generation from the landfills, the project reduces greenhouse gas emissions and mitigates climate change. Sites for municipal waste to energy plants are selected through public consultations. This minimizes the impact on local communities. Residents of the four cities enjoy cleaner streets, air, and water, while the facilities also provide jobs locally.
Future perspective. China's government will play a key role in the integrated solid waste management strategy. Besides increased cooperation efforts between the national government and local governments to encourage investments in solid waste management from the private sector and foster domestic recycling practices. Similarly, better regulation of MSW management for efficient waste collection and separation is needed to incentivize recycling at the individual level by local residents in every city. Nevertheless, without a market for reused materials, recycling will take no longer to become a common practice in China, as Chinese authorities will not be able to stop the waste stream from growing, but can reduce the rate of growth. The government's role in promoting waste management for energy production and recovery is of extreme importance.
So the challenges facing the waste to energy industry in China first is facilities high cost and susceptibility to corrosion. So the incinerator accounts for approximately 50% of the cost of investing in a waste to energy plant as the cornerstone of WTE incineration facilities. So the equipment that are need to use is imported incineration and is very expensive. For the majority of Chinese cities, these costs are not sustainable. The second challenge is the air pollutant emissions and fly ash management. So a number of environmental pollution problems are caused by substandard incineration facilities and flue gas purification systems, and pollutants are also produced during the incineration process. So in this particular situation, emitted dioxins cause severe air pollution. So management of fly ash produced during waste incineration has not been addressed, which leads to the secondary pollution. While during incineration, the amount of waste decreases rapidly, some residues remain, such as bottom and fly ash.
So, evaluation. Waste to energy or energy from waste facilities provide a safe, technologically advanced means of waste disposal that reduces greenhouse gases, generates clean energy, and recycles metal. Waste to energy is widely recognized as a technology that can help mitigate climate change.
So China moves beyond traditional incineration to have a sustainable operation of the plants and effective use of their resources. And with that, China has successfully expanded their waste to energy because the country developed a better solution with the use of advanced technologies. China also has to come up with the idea of building the largest waste to energy plant in the world that will help to address the country's increasing waste management crisis. So the incineration process built in Shenzhen City is a huge help for the country because it also has a double purpose that eliminates the waste while producing energy at the same time around the city.
So thank you.
Thank you so much, guys. The presentation was so beautiful, very interesting. So now it's our turn. So Marisol, you are the first. So let me put the presentation. Wait a minute. Here we have. Let me know when you can see the presentation, please.
We can see it.
Yes, we can see it.
Okay.
So, well, we chose Norway, or well, I chose it. I didn't agree, but I think this is a great country to talk about. And well, I will talk a little about this country and its energy. But well, I stopped watching the presentation. I don't know if you guys can see it. Oh, I can see it now. Sorry. But well, Norway is a major energy nation in Europe based on a completely unique set of resources, which are hydropower, petroleum, and new renewable energy sources such as wind power and biomass. And well, Norway has only 1% of Europe's population, but 20% of the hydropower resources, 50% of the water reservoirs, which are stored water for hydropower production, and 40% of the gas resources, and 60% of the oil resources. And well, some other countries close to Norway are Sweden and Denmark, and those countries have developed their waste technology parallel in most respects. However, comparing with Sweden and Denmark, Norway has not fully utilized energy from waste. This is due to its rich resources of electrical power from waterfalls and fossil resources. Nevertheless, utilizing energy from wastes in Norway is gaining increasing attention. And actually, it is one of the fields that have a great focus at national level. And new plants have been built and planned in the biggest cities and areas of high population density. Can you go to the next slide, please, Felipe? Well, so Norway is a great country with so much potential, and this country does not need this energy from wastes, from wastes, because it has many other sources. But well, I'll talk about waste management in this country. So from 1960 to 1980, the number of landfills in Norway increased heavily. Almost every municipality operated their own landfill as a solid waste treatment method. And well, knowledge of pollutions from landfills in the form of the greenhouse gases methane and carbon dioxide and leachate containing heavy metals and xenobiotic organic compounds were important factors for terminating landfills. The Norwegian government has introduced taxes parallel to new regulations and guidelines for waste management. And can you go to the next slide, please? Well, I will also talk about incineration of waste to make energy. So, incineration of waste has gradually been considered as the best accepted way for end treatment of waste in Norway as in other European countries. Modern integrated waste management will not be equal all over the country. However, because of the strengthened landfill regulations, waste, recycling, and converting to energy becomes more relevant. The burnable fraction of waste comprises products not easy to recycle, such as contaminated paper and plastics, packing, furniture, textiles, etc. The amount of these types of fractions has increased significantly in all Western countries due to an increasing economy and use of throwaway mentality. And increased development of distant warming and use of waste as an energy source are two of the most important initiatives to reduce climate gas emissions and improve air quality in the largest cities of Norway. An important infrastructure to take technology of waste into use is the district heating system. In Sweden and Denmark, the development of such systems is parallel to build plants for waste incineration. And due to the lack of incinerations for waste in Norway, there has been an increasing export of waste for incineration. But today, this export of waste from Norway is mainly to Sweden. And well, Felipe now will talk about the plants in Norway, which are three. Let me
Yes, yes, it is.
on the slides. Hold on a second, please. I'm sorry, this is not what I wanted to present. Can you guys see my screen now?
Yes.
Yes.
Thank you, Marisol. Okay, so now I am going to explain about the project. Well, it is two projects of Norway that have to be able to have more energy, more energy in his country, and well, here you can see the two principal treatment strategies exist for producing energy from waste. For the first one, putrefaction to produce the blue gas, methane, and the second one is the incineration to convert the carbon source of the rest fraction of waste into the end product carbon dioxide, water, and energy. Well, these two projects or strategies are not in conflict with each other since they use different waste fraction and technologies for these two process. Well, this fact is a challenge for planning a sorting system for the population, adapt to the end treatment, and of course, in Norway, the development of recycling waste into energy has increased during the last 15 years, and the system of sorting is well established among the population. And the technology has been developed on optimizing the energy. And well, so Marisol, can you change the well, here we have a diagram, but it's very hard to explain because it's the procediment, the process that these strategies have to do for the project. So better I can explain the results at the final. So in this moment, Marisol, can you change the slide, please? Thank you. And for these two projects, Norway have 3 plants to work. Currently, Norway has 3 plants. The name is very strange, but I am going to only spell it: Haraldrud, Klamstrud, and Romaric Biogas. And well, in many years, the Harald plant was first built, and it has a recycling and sorting capacity of 100,000 tons of waste. The next one is Clemens Root, and this plant is the largest plant with a recycling capacity of 300,000 tons of waste annually. And the last one is the Romari biogas, and well, this is the biggest that it is in Oslo state, and of course it's a biogas plant, and it produces both biogas and biofertilizers based on food waste, and has the capacity to work for 5,000 tons of food waste per year. And for the last, in Norway around thank you, Marisa. In Norway, around the 95% of waste is burnable, and the waste content is generally from food waste to plastics, which has almost the same burning quality as oil. So the percentage of coal, hydrogen, oxygen, nitrogen, and sulfur halogens in the different waste fraction, and determine the amount of energy produced by incineration. And that's it for me. Thank you so much, guys. And now you can change the slide. So thank you so much, guys.
Thank you guys for that presentation. It's really great.
So, well, do you want to compare our countries, or do you have any question about our country?
Not really. It's okay.
I think both countries have like incineration plants, right? So I think the best method to use the waste to turn waste into energy. So I think both countries make it great.
Yes, and it's really nice that they can turn just waste to energy and not just pollute the ecosystem and the environment.
Yeah, mainly in China, which is a very
Populated country. Yeah,
Populated country.
yes, there are a lot of people there.
Have you been to China, guys?
So it's also nice that China come up with a solution that has a double purpose. That has a double purpose on turning waste into energy and producing electricity around the city.
Yeah, I think it's a very smart way to produce energy. So thank you guys.